We are now recording. All right, 9I&J. Technically, you can do these exercises without me. There really isn't much to sort of go through. I'll just give you some terminologies, and then we'll jump right into the CAS, and then we'll just practice sketching on a CAS. Okay, that's really the only part that I will be teaching you. The rest you would have done since year 7. Just in terms of terminologies here, bivariate. The word bi means two. Variates, like variables, so it changes. What's bivariate? Thank you. Bivariate is when you're working with data that has two things that you're comparing. See, unlike before we did box plots, that was called univariate data or one variable statistics. And the reason for that was because we only had one column of data. Now you've got two number lines of data. One is a vertical number line and one is a horizontal. In this particular scenario, we're comparing between weight and height. Okay, so then we're looking at the relationship between two variables. That's when it's called bivariate. Okay, so you either have diagrams for univariate, so dot plots are great for just univariate data. Box plots are also good for univariate data. That's why your NAPLAN does numeracy. They only test your numeracy skills, so that's one data set for numeracy. Then they test your written skills to your comprehension skills. That's why it's done as a box plot, because it's one univariate. Bivariate, you expect it to be either, you can have bar charts, you can have scatter plots, you can have, what else can you have? You can have those histograms, which is kind of like a bar chart, but slightly different in when you use them. So that's what bivariate means. And when they say bivariate data, so that's the kind of data I'm working with. I'm working between two variables, and I'm representing it as scatter plots. Doesn't have to be scatter plots, can be a lot of other things. But scatter plots are just nice because you just plot them on the page, and then you can analyze them. Yeah? So, speaking of last session, I talked about standard deviations, and I used scatter plots to give you the idea of what standard deviation was. Well, then we're going to follow up from this to then find that predicted line. So remember the example where I drew out and I said, imagine one class, I gave them a prediction on the number of hours they study. And this is their ATA score. And then I showed you these dots versus a second class where with the same prediction, and that class had something like this. See, that's a scatter plot that I'm doing there. But from that, you were able to tell me which class would have more trust in my predicting model versus which class wouldn't, right? What you did there implicitly or intuitively was you were able to read the standard deviation. That's what you're reading, the spread of the data. Today's lesson, we're going to learn to how to, one, plot that on your CAS, all those random dots, and two, how do you get that model? Because that's a straight line equation, so there must be some equation that does a best prediction for the set of data that you have. Okay, that's called line of best fit. And that's what we're looking at today. So line of best fit, I'm going to show you how to find that on your CAS. And I'm going to show you how to get those pictures by all these dots on a CAS. So very simple stuff. Cool? Let's fill in a bit of detail so that you understand the purpose. So now you understand standard deviation. Now we're just looking at scatter plots, how do you do it on a CAS, and how do you get the line of best fit. Here we go. Bivariate data include data for two variables. The two variables are usually related. For example, height and weight. Sometimes they're not related. For example, what's one that I remembered from psychology? It was, that's right. People put on sunscreen and fainting. And when we looked at the data, there was a trend like this. Can someone explain to me, this is from a psychology sort of background, what's the problem that it seemed that it was a commonality that the more people put on sunscreen, more people were fainting. So therefore, putting on sunscreen, you're more likely to faint. There's a problem with that statement that I'm saying. Can someone come up with a reason why my statement could be wrong, and what's an alternative explanation for that?
It's probably just from being in the sun.
Yeah, because if you're putting on sunscreen, it's likely it's a sunny day. If it's a sunny day, you might be fainting not because of the sunscreen, but it could be because you're not drinking enough on a sunny day. So this is where we talk about in psychology, we talk about, yes, even though you see a correlation and trend, you got to interpret it in the scenario, are there confounding variables? And a confounding variable means, are there any possible explanations as to why this data is giving us a certain result? And that's it. Yeah, exactly. Very good. So that was one of the things that we talked about in psychology, but that's the idea of, just because I'm saying they're related, it doesn't always have to be. We're just looking at how does the two variables influence each other. Next one, the variable that is changed or controlled is also known as, for those who do science, which is like psychology as well, we call that the independent variable. So independent variable usually is on the x-axis, meaning sunscreen was the product itself. So whether you put on a sunscreen once a day, twice a day, 3 times a day, that's something you can control. The result, so fainting is the result of you putting on sunscreen. That is usually called the dependent variable, because your result depends on what you altered. Okay? So that's the language that we use. We say dependent variable, that usually sits on the y-axis, so that's the results, which follows your equation, y equals mx plus c. X represents what you're changing. So if I put in 1, you get a different y value. If I put in 2, you get a different y value. So y is known as the dependent variable. And then this is known as the independent. So in psychology, we alter that. We alter what you're changing. Okay, so then we test to see how does it affect on the results. And the independence is what we cover. So it could be, the independence could be male versus female. It could be the color of a room. So there's an experiment on, say, does the color of a room influence your emotions? So they found that red colors seem to elicit more aggression from young children. So they're more likely to hit a Bobo doll with like wrenches and toys. Whereas a green room or a blue room, they were less likely to do so. So then they concluded the color of a room must have some sort of influence on your mood. Hence, probably that's why some rooms, they try to keep it white, bright, neutral. Black is obviously too warm. It absorbs light and all that. But that's why you don't have red rooms. You don't come in, you get this weird red room. But that's one of the things that you see. So hopefully that gives you a bit of context, what y equals mx plus c is and what x represents and what y represents. All right, so we got independent, dependent variables. Cool. We then talk about correlation. You're not studying correlation coefficient. You're not working out the power of like how correlated they are. That's for general maths, and you might do it next year as well. But for this year, you just need to be able to tell, is it strong, weak, or no correlation? So strong is that the closer they are to a certain pattern or prediction, that's called strong. Weak is that it follows a pattern, but it's not exactly there. And then no correlation is the one that I usually give to you so that you can see it's so random you can't really tell much from it. So that's the 3 different types of correlation you have. All right, grab out your cows. That's the theory. That's pretty much all you needed to know, which most of you would know intuitively. Let's grab out a cows and practice. How do we sketch a scatter plot on your cows? Here we go. Let's enter this data. Grab out your cows. It's got a new. I'm going to make a new one. Let's go back. All right, on your CAS, we're going to use a spreadsheet. So move your mouse to this spreadsheet-looking Excel icon. I'm going to open it up so it looks like a spreadsheet. So in one column, it's going to be called engine for engine size. Right? So right here, engine. For engine size, I got 1.1, I got 1.2, I got 1.2 again, 1.5, 1.5. What's the other 2 numbers? 1.8, whoops, 1.8, 2.4, 3.3, 4.2, and 5.0. Can someone explain to me why didn't I type A, B, C, D, E, F, G for car? Why didn't I do that? But I typed in 1.1, 1.2, which is just underneath it. Why didn't I do a column for A, B, C, D, E, F, G, H, I, J? Well, yes, it's true. It doesn't have to be on the axis, but also Molly is also correct. It's not relevant. But how do we know it's relevant or not relevant? Una. Good. So we can use that. That's just the number of people, which already this is representing. 1, 2, 3 is the number of data that we have. But another key thing is notice the result. So we're talking about independent events versus dependent events. These are numerical data. So they're numbers. Versus, technically, this is a categorical data. They're naming. So I can't compare a numerical with a categorical data in that particular way that I'm interested in. Yeah? It has to be numerical with numerical in order for you to get a scatter plot that is a data by data. Okay? So, and also I'm not interested in the car, whether it's car fuel or is it car engine, but I could have done it. But in this case, we don't need to. We're interested in engine size and fuel economy, whether that has a relation. So that's why I'm only putting engine. And the other one's fuel, so let's fill it in. So I'll call column B fuel. I go down, it's 21, 18, 19, 18, 17, 16, 15, 20, 14, 11. All right, I've entered all of my data. I've got engine and fuel, and those are the two variables that I'm interested in to see, is there a pattern? Because just looking at the table, it's hard to tell. But in a picture, I may be able to see if there's a pattern or not. So how do you do it? Go to Control, Doc. So press Control, press Doc to add a page. And you're going to do very similar to last lesson with box plots. You're going to add data and statistics. And that's the bunch of data that I've got so far, unorganized. Okay, so I've got, and each of us will be slightly different just because it can plot in any way. So this is why we have to then order what's on the x-axis and what's on the y-axis. So we have to ask ourselves, which one is the independent variable and which one is the dependent? So does the field depend on the engine or does the engine depend on the field? The field depends on the engine, right? So your fuel consumption depends on if your engine is efficient or not. So that means the type of engine you use on each car, each time you change it, it will affect the field. So the y-axis should be field. So on the y-axis, click on it, and I should be choosing the label field because I labeled it field before. Whilst on the x-axis, I said I wanted engine because that's what I'm changing. That's my independent variable. So each engine of each car, I'm going to call the x-axis engine. So now we all should have the same graph. Okay, so we entered all the same data. We should get the same graph. Unless I entered the wrong data. So everyone, can I get a show of hands who got the same graph? Okay, good. Good, excellent. So that's scatter plot. So that's, if we're asking you in the exam, then you do it by hand, but it means we have to give you a scaled axis for you to plot it correctly. Then it will look exactly the same. If we don't give it to you, that means you do have to scale it when you draw it. Make sure to draw the scale. Okay, don't do too many of these exercises just to understand how to do a proper scatter plot. Yep, Control Doc. Press Control. Yeah, and then add on data and statistics, number 6 or something. Very good. All right, team. So once you've got that, you can then analyze it. So what can you say? Is there a correlation between engine and fuel? Yes, there seems to be a correlation in terms of engine and fuel. And is it a strong correlation or is it a weak or...
It's strong and then there's like a gap.
Yeah, very good. So in this case, we can say, and that's where in general mathematics, if you choose that for year 11, it's the analysis. What does this mean? Okay, so why is there a bunch over here and why is that scattered? The interpretation of the data is what we do in general mathematics. In your case, this is all you needed, and you just simply, right, we'll say, is it a correlation? Is it strong or weak? And that's all you need to identify. Yes, weak, negative. Very good. All right, and your next exercise is called line of best fit. There is a mathematical way. There is a mathematical way for you to calculate the line of best fit. You don't need that at this point. You just need to know how to get it. So this is where you can go menu, analyze, go to regression. So I'll say it again, menu, analyze, regression. Oh?
Why is some of them like grayed out?
Grayed out.
Right. If you do it again, you might some of them are grey, like the way.
Really? I'll come over and check yours right after this one. Go to menu, analyze, go to regression, and then see how it says show linear. You can do mx plus b. In general maths, they do a plus bx. Both is the same thing. Okay? So I'm just going to do mx plus b just because that's something we're familiar with. If you do that, it will give you the equation. The equation for the line of best fit. Okay? And everyone should get the same. Everyone should be able to get the same line of best fit. Show linear. mx plus b. Good. So you get a line and you get the equation. So that's the kind of questions we could ask you on the exam. So you just need to know how to do that on your CAS. And that's 9I&J together. Okay, so if you flip over the page, the notes, that's what line of best fit is. It's to give you that prediction model. And they've just calculated the difference between each one. So last session you learned how to find the 5-number summary. So you can do the mean, median, and all that. So that's all you need to know on your CAS for statistics. Okay? That's pretty much it. That's it for our session. That's 9A&9J. Appreciate it. 9I&9J, yeah. 9I&9J. Say that again. Yeah. Which is quadratics, probability, and stats. Oh, did you? Well, I guess for your sake, maybe I can chuck something. No, I probably won't.